Hi guys, very good evening and a warm welcome to Vedantu JEE English. This is your Master Teacher Nabamita Mam and today we are here to solve a lot of questions from periodic properties. Quickly go and call up your friends everybody. Hi Naresh, hi Jaswant, hello Sanjay, hi Ashmita, what's up guys? Very good evening. Quickly go and call up your friends everybody. Go. Till then I will also once inform it in the Telegram channel, right? Come on. Hi Santosh, hello everybody. Hi Chetan. How is your preparation going? All good? How is the preparation? How is the Josh? That's what everybody asks, no? Hi Nandini, hello Yash, hi Srivatsan. Very good evening. Thank you so much Bhanu Prasad. Thank you so much. Hello Sri Harsha, hello Sri Harsha. Sorry. Hi Soham, very good evening bacha. Kaise ho? After a long time, why you did not covering all the high weightage topics? Very good. That's exactly your strategy. Yes. In fact, on Friday, I'm also going to give you a timetable for this last 20 days, what and all you should do. Don't forget to watch that as well. Yes. Very good evening, Ramesh. Very good evening. Quickly go call up your friends, everybody. Let's begin. Let's not waste time. What do you all say? I think I should start. Shall I start? Give me some la in the chat box. Yes, if you all are ready to start with the session. Long time no see. What are you saying? Monday my session had come. You are studying, acha, you are in grade 11. Sanjal, first of all, please complete NCERT. Uske baad you can go for N Avasthi. I would suggest N Avasthi. N Avasthi is very easy. You can understand everything. So, go for N Avasthi. In fact, even I used to study N Avasthi a lot. There are other books as well like Clayden's and all of that, but those are like really high level, okay. For organic chemistry, there is another book by Nimai Tiwari. It's a very easy book. If you want, you can try that as well, okay. Alright. Okay, so I think without much further ado, let us start everybody, okay. Let us start. After finishing high, finally I could, very nice, yeah, very nice. Okay. So let's start with the first question, everybody. Before that, as you all know, my name is Nabamita Mam and I'm your chemistry teacher. I'm your chemistry master teacher here in Vedantu. And now moving on, now that you all are here, do not forget to like, share and subscribe to this channel because you know that this is the official JEE English channel, right? All the information that you get here are of English, are provided to you in English, right everybody? Yes. BK, there are a lot of books that are recommended. See, it depends on you. You asked me, so I suggested that for you, right? I suggested that for you. Like for me, it is very easy, but it could be something else also for you, okay? Don't worry about that. Chalo. Vedantu crash course mock test, the solutions are very short, unable to understand and analyze. No problem, Gokul you can watch these sessions as well, okay? Sri Harsha, about NEET, I think I'll tell you later. Right now, why you ignore me, dude? Come on. Not ignoring, I just answered you. Anyway, chalo, let's start with the first question. Now tell me, this is a very easy question. Let's start with easy and we will go up to the tougher ones. Guys, can we focus here now? Let's focus here. Everybody, focus. Like this. Like this, okay? Chalo. So, the element with Z is equal to 120, which is not yet discovered, yeah? Will be an or a what? What do you think? What do you think it's going to be? Well, we know that the element that has been discovered till now is 118, isn't it? 118 is oganescent, that is OG, correct? OG. OG is the element, right? Now, OG is 118. So, after OG, what do you have to do? After OG, it will be NS2, right? It will be NS2, correct? After OG, all you have to do is add 2 more electrons, right? OG is 118 and OG is in the P block. So, if you just add NS2 for it to be 120, then that means that it is going to be alkaline earth metal. Am I right? Am I right? Anybody who wants to disagree to it? Anyone who wants to disagree to it? Yes. Can you solve it like this or no? Yo guys, B, yes, this is alkaline earth metal. Guys, can I have answers that are related to this chapter? Shriharsha, because the channel name is JEE English now, we will not be focusing on NEET so much, okay? We will be focusing on JEE much more than NEET. And if you really want to follow it, then why don't you go to NEET Made Easy, where Wasim sir is teaching you chemistry there. You can take a look at that channel as well, alright? Yes, or there is NEET English as well. Just find that and you will be able to get sorted for that, okay? Very good. So, option B is the correct answer. Let's check it out. Oh, yes, we are right. Option B is the correct answer. Moving on to the next one. Acha. Similarity in chemical properties of the atoms of elements in a group of the periodic table is most closely related to what? Tell me. Yes, similarity in chemical properties. Acha, chemical properties depend on what? Chemical properties depend on what? Huh? What do you all think? What do you all think? Shri Mura, wow yaar, you are answering from the very beginning. Okay, some of the students are saying A, some of the students are saying D. See, I understand that according to the modern periodic table, yeah, modern periodic law, I understand that the answer should be atomic number, but atomic number also consequently tells you that it should be number of valence electrons. Don't you think so? Don't you think so? Tell me something. As per modern periodic law, it is suggested that everything depends on atomic number, and that's why we have the periodic table, correct? However, even if it is atomic number, consequently it depends on the number of valence electrons, and because of the number, see, you can see NS1 group 1, NS2 group 2, right? And that is why I would say that option D is the correct answer. Number of valence electrons is the correct answer. However, if you search it on internet, yes, you will find different kind of answer, but please go for option D, okay? Please go for option D. Alright? Got it? Okay? Option D is the correct answer. Do not forget. You are just a little late, but no problem. It's okay. Why not A? Like I said, consequently, atomic number is also resulting in number of valence electrons, na? So, when you make a group, alkali metals, all of them, how are they, why are they put in the same group? Because if you see, the number of valence electron is one thing that is common in all of them, right? Alkaline earth metals, NS2, the whole group has NS2, 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 NS2. That's the general electronic configuration. So, once again, number of valence electrons, checks, right? Checks, right? Now, you do that for this and do the same thing for P block, do the same thing for D block, do the same thing for F block. You will find that that is what is common. So, that is why number of valence electrons we will say. Cool. Moving on. The set that contains atomic numbers of only transition element is, chalo batao. If valence electrons is not in the option, then go for atomic number. Definitely, no doubt about it. No doubt about it. If in this question, if this option is not present, then go for atomic number. Definitely, why not? Please go for that. Cool. Moving on. The set that contains atomic numbers of only transition element. Okay. Only transition element, huh? Not inner transition element. Acha, now tell me, lanthanoids and actinoids. What are there, this thing? What are there? We know that lanthanoids is what, from 57 to something, right? 57 to something is lanthanoids, isn't it? Huh? So, which one is the correct answer? 21, 25, 42, 72. I think it's option B. I think it's option B. No, Baba. Check it out again, no? Check it out. What about this thing? What about lanthanum and actinoids? What are their electronic what are their atomic number? If you just know that, then you can find the answer easily. Then you can find the answer easily. Batao, batao. Chalo, let me write it down, huh? Lanthanum, what is it? 57 to 71. Yes, 57 to 71. Now see, okay, and then actinoids are what? Actinoids are, how much was it? How much was it? 89 to 103, isn't it? 89 to 103. Correct? Okay. Scandium is not a... Nah, Srimura, you are wrong. It was the last ones. It was the last ones. No. Aha. You're wrong. You're wrong. What's the correct answer? This, Baba, this. See? 71, 103. So, if there is 72, 72 would be hafnium. Hafnium is a transition metal. Hafnium is a transition metal. Srimura, you are getting confused, bacha. Please check it out again. No. You are wrong. Scandium is a transition metal. Scandium is a transition metal. Okay? Yeah. Anyway, so see, 72. If you remember, I had told you that d orbital cannot be fully filled. The definition said that it has to be slightly filled, half filled, but not fully filled, if you remember, Srimura. That's what I had told you when I taught you, right? So then scandium is a transition metal. You got confused. No problem, it's okay. So 21, 25, 42 and 72, all of them are transition metals. So that means option B is the correct answer, okay? Thank you. Moving on, the correct order of the ionic radii of O2 minus, N3 minus, F minus, Mg2 plus, Na plus and Al3 plus. Chalo, this one you solve it for me. Let's see. Solve it for me. You know, right? What happens to ionic radii? And you know that cations will have the least number. Cations will be much smaller. Cations will be much smaller because lesser number of electrons and the protons will be able to hold it very, very nicely. What is ionic radii? Tauba. Ion, radius of an ion, that is ionic radii, okay? Yes. Okay, Al3 plus, Mg2 plus, Na plus, F minus, O2 minus, N3 minus. Very good. Option C is the correct answer. Very good. Yes. Very good. Who was the first one who answered? Rahim. Yes, Rahim, you are right. Absolutely right. Absolutely right. Very good. Very good evening, bacha. Good evening. Yes, option C is the correct answer. You understood, no? See, very easy. The easiest trick here was that Al3 plus. This is a cation. Cations are always smaller in size than anions because they have already given up their electrons. That means that the number of protons are higher in the atom than the electrons. If the number of protons are higher, that means the positive charge will be able to hold on to the negative charges very easily, right? Yes? So that is why I know they are isoelectronic species, but even then cation will have a smaller size. Yes, cation will have a smaller size. Hi Akshay auntie. Hello. Hello. Next question. The elements with atomic numbers 101 and 104 belong to respectively. Hey, 101 is definitely belonging to actinoid series, right? From 89 to 103. 89 to 103 is actinoid. So that means this is a inner transition element or F block. This is an inner transition element or F block, correct? Inner transition or F block. That means actinoid. And 104 will belong to 101, 103, right? What am I saying? Actinoids are basically 89 to 103 and all of them belong to group 3, correct? All of them belong to group 3. Now that means that 104 will be just next to it, group 4. Group 4, am I correct? So that means it will be actinoids and group 4, option C. Correct, Aita? Correct? Seri? Yes? Got it? Do we understand this? Amazing. Okay. Actinoids and group 4. Yes, option C is the correct answer. Wow, we are solving everything. Why not B? You tell me, bacha, why will it be group 6? Shuna, Gopichand, you tell me, how will it be? See, all the actinoids and the lanthanoids, they all belong to group 3. Now, from 89 to 103 belongs to group 3 already. So, if it is 104, it will belong to the next group, right? It will belong to the next group, isn't it? So that means that it will be group 4. Right? Understood? Gopi-chan, did I make it clear? Did I make it clear? Okay, moving on now. Yeah? Which the process is not endothermic in nature. Which one of these are not endothermic in nature? Any idea? Any idea? See, now argon, right? Argon is what? Argon is a noble gas. Argon is a noble gas, right? Now, what is this reaction showing you? What is this reaction showing you, my dear bacha? Huh? What is this showing you? Option B. How did you find that out, Bhanu? How did you find that out, bacha? Endothermic means that energy is absorbed and not released. Now, argon is a noble gas, correct? Argon has its octet rule already. Argon has its octet rule all figured out, right? Argon has maintained its stability. If you want to disrupt the stability, right, you want to give it another electron. Argon does not want an electron. Argon does not want an electron. So if you want to give it one electron, you will have to give energy to push that electron, right? If you want to give it an electron, you will have to give some energy. So that means that this is endothermic. You are giving energy. It is absorbing energy. Absorption is happening. That means endothermic, right? That means it is endothermic. Am I right? Am I right, bacha? Yes? Do you understand this? Option A is clear. Why this is endothermic? Why this is endothermic? Is this clear? Somebody said, ma'am, why you are confusing? Sorry. My mistake. Sorry, my mistake. This is clear? Okay. Now, let's understand option C. Oxygen has negative O minus. See, O minus. That means that you have already given it an electron, right? It has one electron extra. Now, if you try to give it another electron, you have already given it this electron, the previous electron and the second electron, they will fight. They will have a repulsion. So again, you will have to push the electron inside. That means you will have to give energy. If you give energy, that means the system is absorbing energy. That means it is endothermic, right? Is that option C clear? Option C is clear? Yes, option C is clear. Got it? Now third, see, sodium is giving out one electron. Sodium is giving away one electron. That means what? It is ionization. And what is ionization energy? Ionization energy means how much energy are you giving to take away one electron? Once again, energy is absorbed. Endothermic, right? The only one here where you will be getting stability, this is the one that is exothermic. I don't know why I said ulta. But now do you understand, everybody? Is this clear? Is this clear? Is this clear? Is this clear now? Come on, come on, come on, come on, come on. Now tell me. Everybody, did you understand? All clear? Clinic all clear? La la la. Full clarity? Thank you so much, Arvind. Full clarity. Yes. Okay, cool. Moving on then. Okay. Option B is the correct answer. Chalo, moving on. The ionic radii, again ionic radii, another question is O2 minus, okay, F minus, Na plus and Mg2 plus are in the order of, acha, tell me this. You know the answer. Again, you know that cations will be smaller. Cations will be small. Explain about B. I just did know, bacha. I just did know. See, here what is happening is you are disrupting the stability. If you are disrupting the stability, then what will happen? It will not want to take it. You will have to give energy to push it. But here, hydrogen will gain stability when you give another electron. That is why this is exothermic and the other ones are endothermic. Understood? Yeah? Okay, somebody is saying option B, somebody is saying option A. What will happen? Chalo, let's solve it. An ion is larger. Absolutely right. Okay. How many? What is the atomic number of oxygen? What is the atomic number of oxygen? I have written it down already. Fluorine, 9. Right? Sodium, 11. Magnesium, 12. Correct? Now, let's see. O2 minus. If it is minus, then how many electrons does it have now? How many electrons does it have now? Somebody is saying 11, 12. Very good. Okay. Okay. Very good. So we understand that Mg2 plus, right? Mg2 plus, that means Mg will be 10. All of them are basically 10 only, right? All of them are basically 10 only. Now do we understand that Mg being a cation, 2 plus, it will be the smallest one in the size, right? Magnesium will be smallest. Isoelectronic, absolutely. Then what do we have? Another cation, so Na plus, this will be the second one, right? Then we will have what? Then we will have F minus, because 1 minus anion, and then finally we will have O2 minus. That means that this corresponds to option B, right? Option B is the correct answer. O2 minus, F minus, Na plus, Mg2 plus. Yes, option B is the correct answer. Option B is the correct answer. Very good, Madhav Roy. Madhav Rao, very good. So glad that you remember it. Well done, well done. It is B. Yes, it is B. Absolutely right. Next, acha. Among the statements 1, 2, 4, the correct ones are beryllium has a smaller atomic radius compared to magnesium. It does, right? It does. Down the group, atomic radius increases. So beryllium does have a smaller, and beryllium is what? On the top, beryllium, magnesium, calcium, strontium, right? So beryllium, yes, this is correct. This is correct. Beryllium has higher ionization enthalpy than Al. Agreed. Beryllium has what? 1s2, 2s2. But aluminium will also have 2p1. Correct? Aluminium will also have 2p1. Yeah? Correct? So that means this is also true. Now charge by radius ratio of Be is greater than that of aluminium. Is that right? No. Is that right? Both beryllium and aluminium form mainly covalent bonds. Aha! That's not possible. That is possible. 3 is wrong. 3 is wrong. This is right. Yes, both beryllium and Al, they do form mainly covalent bonds, which we know, right? So beryllium has smaller atomic radius compared to magnesium. Beryllium has higher ionization enthalpy than Al, obviously, right? Charge by radius ratio of beryllium is greater than that of aluminium. Not possible. This is wrong. Definitely wrong. Both beryllium and aluminium, they do form mainly covalent bonds. Also, they have diagonal relationship. They have diagonal relationship. Do you remember that? Beryllium? Yes. Yes. Great. Okay. Moving on. The 5 successive ionization enthalpy of an element are 800, 2427. 3658, 25,024, 32824 kilojoule per mole. The number of valence electron in the element is, okay. Acha, see, everybody, let me show you here with this, okay. See, 800, okay, 2427, not too much increase, 36258, not too much increase, but from this, 25,024, that's a lot of increase, right? That's a lot. Like suddenly it has reached here to the top. That means that taking out first 3 electrons was somehow alright. But the 4th electron was not at all acceptable by the atom. It tried really hard to not give away the 4th electron. Am I right? Am I right? So that means, can we understand that the number of valence electron must be option 3? Option 3 is the correct answer. It must be 3. Am I right? Am I right? This is how we understand this. Yes? 3 has to be the correct one. 3 has to be the correct one, right? Okay, moving on. Next question, everybody. Next question. In general, the property magnitudes only that shows an opposite trend in comparison to other. Oh, we all know this. What is the answer here? What is the answer here, Priyanshu Thakur? What? Why? What? Why? You saw the data, no? The data was given to you, na, bacha? Data was given. Ghost gaming, how 3? Acha. Okay, one more time I'll explain it to you, bacha. See, first ionization enthalpy is 800. That means it is very low, right? It is very low. Second ionization is 2427. The difference between the second ionization energy and the, I'm so sorry, oh, where were you? Here. Okay, now not understood. Chalo. Let's do this. Oh, this mic is troubling me so much. I'm gonna hold this, you know. I think I'm just gonna hold this. It's troubling me too much. Huh. Okay. IE1 is equal to 800, right? Okay, this is a low value. This is quite a low value, okay? Second, IE2, 2427. Do you see this? Do you see this, everyone? Yes? So that means, do you see that the difference between this and this is not so much? Yeah? Then you have IE3, which is 3658, okay? That means that here also the difference is not so much. Now take a look at IE4, which is 25,024. Now do you see what is the difference, bacha? Do you see what is the difference, Ghost Gaming? Yes, the difference is a lot. This is 4-digit, this is 5-digit here. Yes. So that means that the atom had trouble giving the 4th electron away, which was definitely from a lower orbital. Yes. That is why we say that option 3. 3 electrons were in the valence shell. It could give it away. It could give it away. But the 4th electron, it was tough for the atom and it did not give it. It tried very hard to not give it away. Now do you understand? Ghost Gaming, very nice name. Yeah, Ghost Gaming. Chalo, moving on to the next question. Okay? This everybody knows, no? Thank you, Ashwan. Thank you so much. In general, the property magnitudes only that shows an opposite trend in comparison to other properties across a period is atomic radius, Baba. All of them, what happens is, yes, atomic radius, what happens? It decreases. Option D is the correct answer. We all know that. Huh? We all know that. And this has come in mains. This has come in September 16, 2020 mains. If these kind of questions come, you can easily crack it. Chalo. The 3 elements. You are given 3 elements, X, Y and Z. All of them are in the 3rd period of the periodic table. The oxides of X, Y and Z respectively are basic, amphoteric, acidic. Now, the correct order of the atomic numbers of X, Y and Z are, what is it? Acha, we know that non-metallic oxide, if you go in the period, right, in the period what happens? Non-metallic oxides are acidic in nature, right? They are more acidic in nature, isn't it? So definitely it will be what? X, Y and Z. So that means option B. Option B is the correct answer. That's it. Very easy, right? This has also come in September. This has also come in September. That's it. IS delta. Very good. Why are you doubtful? Option B is the correct answer. Next question. Acha. Boron has a smaller first ionization enthalpy than beryllium. Consider the following statement. It is easier to remove 2p electron than 2s electron. Right. Right. Boron has 2p1. Beryllium has 2s2. So obviously it will be correct, right? Now 2p electron of B is more shielded from the nucleus by the inner core of electrons than the 2s electron of B. 2s electron has more penetration power than 2p electron. Atomic radius of BE is more than BE. Okay, which are the correct ones? Tell me. Which are the correct one? Somebody said B. Why B? Why B? B is not possible, bacha. B is not possible. I told you the first one is anyway true. First one is true. Atomic radius of boron is more than beryllium. This is wrong. This is wrong. Beryllium atomic radius decreases, no? Atomic radius decreases, isn't it? So beryllium will be larger, not boron. Now, then, so yes, option C, 1, 2 and 3. It is easier to remove 2p electron than 2s electron, absolutely right. 2 2p electron of Be is more shielded from the nucleus by the inner core of electrons than the 2s electrons of Be? Absolutely. Absolutely. Write down the electronic configuration of boron and beryllium. Chalo, let's write it down. Boron and beryllium. Beryllium is 1s2, 2s2. Boron is 1s2, 2s2, 2p1. So, 2p electron of boron, yes, 2p electron of boron is shielded from the nucleus, yes, see, 1s2, 2s2. Yes, but here, this is getting shielded only by 1s2. So, obviously, option 2 is also correct, right? And then 2s electron has more penetration power than 2p electron. Absolutely, yes. That is also true, right? So, that means option C is the correct answer. Got it? Clear? Everybody? Clear? Chalo. Now, the acidic, basic and amphoteric oxides respectively are acidic, basic and amphoteric. Hey, you know this, guys. You know this. This is very easy. Al2O3 definitely is an amphoteric oxide. Li2O, yes, this is definitely Li2O. Metallic oxides are always basic in nature, right? And nitrogen, this is definitely acidic in nature. Option C. So easy. So easy. Right? Next question. Chalo. The first and the second ionization enthalpy of a metal are 496 and 4560 respectively. How many moles of HCl and H2SO4 respectively will be needed to react completely with 1 mole of metal hydroxide? Acha chalo, see, metal hydroxide is given, metal hydroxide is given, that means it should be MOH, right? Metal hydroxide, MOH, correct? Yes. Now, what will happen is, it is asking you how many moles of HCl and H2SO4 will react with 1 mole, correct? 1 mole. So, that means I can write here HCl will give you what? It will give you MCl plus H2O, right? Now, since, how do we find out which is the metal? How do we, Bhanu Prasad, please focus, no Baba, please focus. Again, I'll make mistake. Don't, this thing, see, I'm not feeling well right now. Suddenly my stomach is also paining a lot. So, please just focus here. Don't break my focus. I'll not be able to. My back is paining, my stomach is paining. I'm not able to stand anymore. Let's do this, yeah? Please focus up, bacha. And then again, from 9 o'clock, I have another session also. Please focus up, okay? We will talk about everything else later on, okay? Okay? We'll talk about everything else later on. Now, see, 496 is a very low energy, right? 496 kilojoule per mole is a very low energy. But if you see the second one, 4560, the difference is a lot. The difference is a lot. That means it definitely belongs to the first group. It definitely belongs to the first group, isn't it? Right? It definitely belongs to the first group. Now, it is said that here it is 1 mole. Here it is 1 mole. And here also it is 1 mole, and we can see that here also it is 1 mole, right? And here also it is 1 mole, correct? Now, if I do it for H2SO4, what will I see? MOH plus H2SO4 will give you what? M2SO4 plus same thing, right? Now, what do I see here? Now, what do I see? This is 1 mole. This is 1 mole, correct? This is 1 mole. Now, here also it should be 1 mole. But is this 1 mole? If I have to balance it, then I will have to write 2 here, right? If I have to balance this, I'll have to write 2 here. If I write 2 here, then that means that it will be 0.5. If I write 2 here, then as per the question, it is written 1 mole has to react. If here it is 2 mole, then it is 1 mole. That means half of it. That means it is half of it. So, that gives us option D as the correct answer. 1 mole, 1 mole, 1 mole. But here if it is 2 mole and 1 mole, that means it has to be 0.5. Agreed? Clear? Agreed, everybody? Am I clear here? Am I clear, bacha log? Sorry. Clear hai? Or no? Yes. Okay. Chalo, moving on then. Moving on. The first ionization energy in kilojoule per mole of sodium, magnesium, aluminium and silicon respectively are. Ionization energy, what happens to ionization energy across the period and across the group? What happens to ionization energy across the period and across the group? Ionization energy increases. Across the period, increases. Down the group, decreases, right? Across the period, increases. Down the group, decreases. So that means what will happen? What will happen? Go, answer. What is the answer? What is the answer? Sodium, magnesium, aluminium and silicon. Let's write it down. Let's write it down. Na is in the first group, then it is Mg, right? Then what will happen? Then aluminium is this side. Yes? Yes? Then option B you all are saying. Are you sure? Are you sure? Ascending order. Clear? Pakka? Option A is the correct answer, guys. Option A is the correct answer. Sodium will have the least, no? Ionization energy, what happens? Increases across the period, right? Magnesium, why will magnesium be higher? Why will magnesium be higher? Half filled. Remember, half filled. Magnesium will have half filled. That is why it has more stability. Because of stability, ionization energy will also increase, right? Yes. And then there is aluminium and then finally it is silicon. So this is the correct answer. Okay. Now the increasing order of the atomic radii of the elements is, okay, increasing order of the atomic radii of the following element is what? Batao. What do we know about atomic radii? Atomic radii, we know that, let's see. Atomic radii from this side to this side, what will happen? Decreases, right? Decreases. Across the period, decreases. Down the group, increases, right? Down the group increases. So that means that COF, correct? Okay? COF. And then what happens? Down the group it increases. That means fluorine, chlorine, bromine. Yes? Fluorine, chlorine, bromine. So what do we find out? What do we find out from this? Bromine will have the most. Agreed? Bromine will have the most. Bromine, after that chlorine. Then it will be carbon, oxygen and fluorine. Isn't it? Isn't that right? Yes. This is the correct answer. This is the correct answer. Yes, fluorine is the least. From here also, fluorine will be the least. Yes. Then comes oxygen. Then comes carbon. Then comes your chlorine. And then it will be your bromine. So yes, it's this. Option C is the correct answer. Got it? Clear hai? ठीक है? चल, moving on. The electron gain enthalpy in kilojoule per mole of fluorine, chlorine, bromine and iodine respectively are. हाँ, ये बता दो. Let's see how many of you can solve this question. Let's see how many of you can solve this question. बताओ. What is the answer? Explain again. अच्छा, ठीक है. How many of you did not understand this? How many of you did not understand this, guys? Did you all understand or no? Do you want me to explain this again? Once again, bacha, we know, okay, atomic radii, no? So we know that atomic radii decreases across the period. Down the group, it increases, right? So if it decreases across the period, that means that carbon will be of bigger size, then oxygen, then fluorine. And as per the top to bottom, right, in the group also, what happens in the group? It increases down the group. That means that fluorine will be lesser than chlorine and then bromine. That means that bromine is the highest because bromine is down the group, right? So that means that bromine is the biggest one. then comes chlorine, then comes carbon, then comes oxygen, then comes fluorine. And that way, option C is the correct answer. Understood? Yes? Chalo. Moving on, next question. The electron gain enthalpy in kilojoule per mole of fluorine, chlorine, bromine and iodine respectively. Sorry, ye bata do. Tell me this answer, guys. Tell me this answer. Why option C? Why option C, guys? Why option C? Everybody is telling me different answer. Chalo, let's check it out. What is the answer? Let's check it out. What is the answer? It is this, the electron gain enthalpy. Acha, tell me, how does electron gain enthalpy, electron gain enthalpy change? How does electron gain enthalpy change top to bottom? Chlorine has more. Iodine's electron gain enthalpy will be the least. Yes, iodine's electron gain enthalpy will be the least. Then it will be definitely bromine. Then chlorine and fluorine. Why is chlorine more? Why does fluorine have less? If you remember, fluorine is the top element. It has a very small size, right? It has a very small size. That means it does not want to gain enthalpy. It does not want to gain enthalpy, right? And that is why electron gain enthalpy becomes less negative top to bottom, right? It becomes less negative top to bottom. But here, what happens is it changes. This is an exception between fluorine and chlorine. This is an exception. Hence, option C is the correct answer. Do we understand this? Do we understand this, everybody? Yes? Do we understand this? Dina, no. No, Dina, no. You're wrong. Yes? Do we understand this, everybody? Is this clear? Yes. Okay. Moving on. Now, I'm going very slow, bacha log. I'm going very slow. So, if you don't understand something, do let me know so that I can revisit the question. Now, within each pair of elements, fluorine and chlorine, sulfur and selenium, and lithium and sodium respectively, the elements that release more energy upon an electron gain are, wow, very easy again. We have just seen that chlorine will be, we have just seen that, right? For chlorine, chlorine will definitely do it. Chlorine will definitely do it. Then sulfur, selenium. Sulfur will be more, right? Lithium, sodium. It will be lithium, right? Option B is the correct answer. Yes, option B is the correct answer. Very good. Next question. In comparison to boron and beryllium. This is a repetitive question. Just some days back only we did this, no? Some days back only we did this. It is lesser nuclear charge and greater first ionization and enthalpy. Lesser nuclear charge, yes, and greater first ionization enthalpy, because beryllium has 1s2, 2s2. To take away one electron from here, it is tougher, but boron has 1s2, 2s2, 2p1. It can easily give away the electron. So that is why this beryllium will have greater ionization enthalpy, however less nuclear charge, because protons are less. Beryllium has 4 atomic number and boron has 5. Correct? Great. Okay. Now, next question is, this is done. The correct order of the atomic radii of carbon, cesium, aluminium and sulfur. Ayyo, very easy. Very easy. Tell me, correct order of atomic radii is, batao. We did this. Yes, we did this, Nandini. Absolutely right. Chalo, batao. What is the answer to this question? Atomic radii, there are a lot of repetitive question about atomic radii. Please, atomic radii ko thoda sa dhyan se pad lena. Atomic radii is important. Cool? Very good. Option A is the correct answer. Option A is the correct answer. Cesium is at the bottom. Aluminium is in the P block, right? Then carbon, sulfur, aluminium, it's all on the P block, and cesium is here. So cesium definitely has a very big size, because cesium is at the bottom, plus it is in the S block. Plus it is in the S block, correct? So that way this will be of the bigger size. Now, the correct option with respect to Pauling's electronegativity value of element. Acha, what happens to electronegativity value? Electronegativity value, just like any other property, yes, what happens? Across the period, increases. Top to bottom, what happens? Top to bottom? Tell me. Definitely, everybody got it right. Option B is the correct answer. But what happens to electronegativity from top to bottom? Achha, since you all know the answer, very good, theek hai. Option B is the correct answer. Well done. Chalo, moving on, next question. The 71st electron of an element X with an atomic number of 71 enters into the orbital of, any idea? Any idea? Any idea, guys? Someone is saying 6S, someone is saying 5D. 5D is the correct answer, definitely. 5D is the correct answer. Good. 4F, 5D, 4F, 5D. Chalo, theek hai. I'm going to erase this. Let's find out. Let's find out what is the correct answer. Explain. Explain why. Explain. Let's do this again. Now people are coming to the correct answer. Somebody said 5D, somebody said 4F. What was the atomic number for lanthanums? What was the atomic number for all the lanthanoid series? Easy, ma'am. 4F because it is D block. Really? Indresh? Why will it be 4F if it belongs to D block? If it belongs to D block, then why will it be 4F? Guys, it is 5D, no? It is 5D, Baba. It is 5D. Okay? It is 5D. Alright. Chalo. 4F because it is D block. No, Baba. Yes, it is 5D. Chalo. Moving on. Moving on. Acha, by any chance, if you want the explanation as well, let me tell you this also. Let me tell you this also. Theek hai. If it is 71, then what is the previous noble gas? What is the previous noble gas? Xenon. If it is xenon, then what will I write? What will I write? Xenon. Very good. Explain. Explain. I am explaining. Then 4F14. Yes. After that. After that. After that. Write down the electronic configuration of 71. You know the explanation. Arun, all of you are asking me to explain, no? Just write down the electronic configuration for this. You will find the answer. You will find the answer. Yes, it is 5D1. It is 5D1, right? It is 5D1. 4F14, 6S2, 5D1. This 5D, that is why. Okay? Yes. Yes. Mr. Silent, write the electronic configuration, only then you will be able to understand that why it is this. Okay? Chalo, moving on. In general, and Mr. Silent, please take a look at the exceptions one more time. Exceptions, do not forget the exceptions. Chalo. In general, the properties that decrease and increase down the group in the periodic table, which one decreases, which one increases? Acha. Down the group, which one increases? Electronegativity does not. Electronegativity does not. Again, electron gain enthalpy also does not. Atomic radius, this is the correct answer, right? Atomic radius increases down the group? Yes, option C is the correct answer. Electronegativity decreases down a group and atomic radius increases. Correct? Very good. Chalo. Correct order of electron affinity is, correct order of electron affinity. What is electron affinity? 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 What is electron affinity Good, Arvind, very good. It is this. Correct order of electron affinity is chlorine, then fluorine, and then oxygen. Once again, you know the trend, no? You know the trend. From the trend, you can find it out. No, Singham, you are wrong, bacha. You forgot the trend or what? What happens to electron affinity? Across the period, down the group. Down the group and across the period, what is the trend? You find out the trend and then solve it, okay? Don't forget the trend, bacha. Chalo, both lithium and magnesium, they display, this is also repeated question, bacha. We have done this some time back only. Yes, both form basic carbonates, that's wrong. Lithium does not form a basic carbonate, magnesium does, okay? Option A is the correct answer. Now, the group having isoelectronic species is, solve this, very easy. Solve this, I'm not telling you the answer. You can solve this, this is very easy, you all know the answer. Till then, I'm going to drink some water. Also, let's run a little, I have another class. I have another class, guys, let's run a little. Okay. Most of you are telling me it is option A. Let's see. Absolutely yes, option A. Okay, absolutely yes, option A. Now, what happened to this? What happened to this question? Okay, let's try to solve it. I think I'll need the question properly. No, what happened to this question here? First, second, third. Okay, let me see if I have if I have the Google slide. From Google slide to this thing, skip. No, why should we skip? Wait a second. Let me find out the Google slide. From the Google slide, we can do it. Just a minute, huh? Acha, found it. Here, this is the question. This is the question. Do you see? No share, no share, no share. Here is the question. Now see. Now tell me the answer. From Google slide to PPT, this is what happened. Batao, what is the answer? Now tell me. Acha, check it out, okay? Check it out. Let's find it out. First ionization energy is 899. Second is 1757. Third is very high. Okay. 737, 1450, 7731. Very high again. That means that the first and the second it can easily lose, but the third one it is not able to lose very well. That means that both A and B belongs to group B, group 2, yes, because first and the second the difference is not so much, right, bacha? The difference is not so much between the first ionization energy and the second ionization energy. So yes, both of them belong to group 2. They can lose 2 electrons very easily. Now what happens is, here we can see that this is a little lesser. If this is little less, this is also little less. That means A comes on the top and then comes B, right? B, where B comes below A. Correct. Absolutely correct. That means option C is the correct answer. Very good. That means option C is the correct answer. Absolutely right. Yes. Next question. Which of the following atom has the highest first ionization energy? Which one of them has the highest first ionization energy? Tell me something. Potassium, rubidium, sodium, all of them belong to group 1, right? Group 1 can easily lose its electron, right? Group 1 can easily lose its electron. But scandium, however, will not be able to lose it as easily as the group 1. So that means that it is option B. That means that it is option B. Alright, agreed? Moving on. The following statement concerns elements in the periodic table. Which of the following is true? Let's read the options. For group 15 elements, the stability of +5 oxidation state increases down the group. Not at all. When you go down the group, the lower oxidation states increases because of inert pair effect. Remember? Because of inert pair effect, right? So that means no, in group 15 actually +3 oxidation state increases. So no, that's wrong. This is wrong. Elements of group 16 have lower ionization enthalpy values compared to those of group 15 in the corresponding. Group 15 is what? Group 15 and group 16. Oh yeah. Group 15 has this thing, half filled, right? Group 15 has half filled. So this is right. This is right. The group 13 elements are all metals. Nah, no. In P block, there are metals, metalloids and non-metals. So no. All the elements in group 17 are gases. No. Bromine is a liquid. Bromine can be found in liquids. So no. All of them are wrong. Option B is the correct one. Okay? Moving on. The ionic radii in angstrom of N3 minus, O2 minus and F minus are respectively what? N3 minus, it is anionic plus it has more electrons, right? So 1.71 O2 minus and F minus. So I guess option A. I guess option A. Yes, it is option A. It is option A. Very easy. Next, in the long form of periodic table, the valence shell electronic configuration of 5s to 5p4 corresponds to elements present in. Very easy. 5 is the principal quantum number, right? Principal quantum number here is 5. Principal quantum number is 5. That means that period will also be 5. Yes, that means that the period will also be 5. Now, the valence shell is 4 plus 2, 6. 4 plus 2 is equal to 6. That means that, and it is in P block. That means 10 plus 6 is equal to 16 group. This is the formula. That means option C is the correct answer. Yes, this is the formula. Do you all remember this? This is the formula. Ticket to find out. You might be asked questions like this. Now, which of the following series correctly represent relations between the elements from x to 1? If one of the element is x and another is element y, then which relation actually explains it correctly? Tell me. Lithium and potassium ionization enthalpy increases. No. Fluorine, bromine, electron gain enthalpy negative sign increases. No. Carbon, germanium, atomic radii increases. Yes, absolutely yes. Argon to xenon, noble character increases. No. Option C is the correct answer. Option C is the correct answer. Oh yeah. 5 more minutes. Let's complete it. Yeah. Let's complete it. I have to go. I have another class, Baba. I have another class. Guys, come on, faster. Which of the following arrangement represents the increasing order smallest to largest ionic radii of the given species? O2, S2, N3 minus and P3 minus. Can you do this? Can you do this? How? Garima. Atomic radii increases down the group, no? So that is why. Okay. Garima, just read the trends once. Okay, bacha? Just read the trends once. You will understand. Okay? Acha, this one. Tell me. Yes, option A is the correct answer. Option A is the correct answer. Which of the following represents the correct order of increasing first ionization enthalpy for calcium, barium, sulfur, selenium and argon? Increasing. Argon will definitely have the highest. Absolutely right. Ionization enthalpy anyway increases. So then it will be ionization enthalpy increases. Sulfur, selenium, calcium, barium. What do you think? I think option C. Yes, option C is the correct answer, right? Option C is the correct answer. Yes. Chalo. The order of increasing sizes of atomic radii among the elements OS, Se and As. Ha, so easy. Order of increasing sizes. Increasing sizes. So O, S, Se. This is definitely all in the same group. Yes. Yes. Then what is the answer? What is the answer? Atomic radii. Atomic radii. Yes. Option D is the correct answer. Option D is the correct answer. Now, identify the correct order of acidic strength. Carbon dioxide is highly acidic. This is highly acidic. This is neutral. This is neutral. This is basic. This is weak basic. This is weakly basic. Copper oxide. So that means that, this option A is the correct answer. Option A is the correct answer. Okay. Yes, I am. The correct order of radii is, what is the correct order of radii? Again, same question. Same kind of question, all about atomic radii. Bacha log, so that means you understand that from how to decide acidic strength. Madhav, non-metallic oxides, non-metals are usually, non-metallic oxides are acidic in nature, metallic oxides are basic in nature, right? And hydrogen has, water, we all know that it is neutral, isn't it? Yeah. Now this one here, right here, it belongs to the what? Calcium, S block. This is in the D block, right? So that's how. Okay, that's how. Madhav, just understand this. Carbon dioxide, it's a non-metallic oxide. Non-metallic oxides are always very acidic in nature, right? Metallic oxides are basic in nature, correct? From there onwards, we know this, okay? Now, the correct order for acidic strength again, okay? Acidic strength, what will happen to acidic strength? What will happen to acidic strength, everybody? Option A is the correct answer, but why? But why? PSCl, no? PSCl, acidic strength increases. Acidic strength increases. So that means option A is the correct answer. Okay. Next, amongst H2O, H2S, H2Se and H2TE, the one with the highest boiling point is, obviously H2O because of its hydrogen bonding. Hydrogen bonding is very strong in water, that is why it will be option A. Okay, moving on. Which has the most stable plus oxidation state? Which has the most stable plus oxidation state? The one that is in the lowest. Which one is the lowest? Which one is in the bottom? Plumbum. That is why option B. Okay, option B. Next, amongst the following elements whose electronic configuration are given below. Hey, this is also a repeated question. We have done this. Option B is the correct answer, isn't it? 3s2, 3p3. Half filled. That is why half filled. This is also half filled, but see it has 3D. But because it has 3D, right? It has 3D also, isn't it? And anyway, down the group, what will happen? Ionization energy decreases. Top to bottom, ionization energy decreases. This is 3s, this is 4s. So obviously, this will have higher ionization energy, right? Correct? Moving on. Which one of the following is the strongest base? Strongest base. It is nitrogen. Nitrogen will have a, NH3 will be a stronger base, okay? NH3 will be a stronger base, okay? Next, which one of the following is the smallest in size? Which one is smallest in size? Cation. Cation will always be smaller size. Na plus will be smaller size. See? Just do this, you can understand. Lanthanoid contraction is responsible for the fact zirconium and Y have about the same radius. No. Niobium and zirconium have similar oxidation state. Nah. Zirconium and hafnium, yes, see, Zr and then comes hafnium, and hafnium is after the lanthanoid, this thing, right? After the lanthanoids, then comes hafnium. So option C is the correct answer. Very good. Atomic number of unyl anium is nomenclature. Anybody? Nomenclature? Unyl anium. So 1, nil is 0, anium is 1. So 101. That's the correct answer. Very easy. First, second and third ionization enthalpies of 4 atoms with atomic numbers n, n plus 1, n plus 2 and n plus 3, where n is lesser than 10 are tabulated below. What is the value of n? Okay, let's see. This one we have to solve it. It's 9:15 already. I have to go. Guys, come on. Fast. Let's do it. This is very low. 496. N plus 2, 496 is very low. It can give away 1 electron very easily, right? Less than 2, less than 10. N plus 3 is 738. That means all of them belongs to, has to be 9. Value is 9, yes. We can see that, see, this is very low. Yes, this is your hint. This is your first hint. Delta IH is very less, means electron is removed from first group. Okay. And then from second, delta H2 is high because electron is removed from the next lower shell. So N plus 2 will give you 11, that is sodium. N plus 3 is 12, magnesium, and N is equal to 9, that is fluorine. So N is equal to 9, okay, N is equal to 9. Moving on, the options with only amphoteric oxide, again you know this has come in advance, so that means 2 options are correct here. 2 options are correct here. This is correct, ZNO, Al2O3, yes, Cr2O3, BeO, this is also the correct answer. Option A and D are correct. A and D are correct, okay. Alright, you know what, take this as an assignment. Take this as an assignment, solve it and tell me the answer properly in the comment section, okay. Now, the radius of La3 plus atomic number La is equal to 57 is 1.06 angstrom. Which one of the following given below will be closest to the radius of Lu3 plus atomic number of Lu is equal to 71? Does anybody know the formula? Does anybody know the formula? Have you solved this or no? गरिमा पहले ये तो कर लेते हैं, पहले ये क्लास तो खत्म कर लेते हैं. अच्छा, we know that R is directly proportional to what? It's inversely proportional to 1 by Z, right? I mean, sorry, directly proportional to 1 by Z, isn't it? Now, how do we solve it? How do we solve it? Huh? R1 by R2 is equal to Z2 by Z1. R1 by R2 is equal to Z2 divided by Z1. Now compute it. What will you get? You will get 0.85. This is your formula, okay? This is your formula. Don't forget it. Next. The first ionization potential of Na, sodium, is 5.1 electron volt, and the value of electron gain enthalpy of Na plus. Ionization potential, okay, see, take a look at this. Take a look at this, everybody. Ionization, right? That means, okay, opposite of this is electron gain enthalpy. That means Na plus E minus, it will give you Na minus. So if this is 5.1, can I say that opposite will be minus 5.1 electron volt? Right? Common sense question. Next, which of the following factors may be regarded as the main cause of lanthanoid barf? What an easy question. Everybody knows this. Pure shielding effect of one of the 4f electron by another in the subshell. We all know this. Oh, we have come to the end. We have come to the end. So that's all for today, guys. Now I have to run because I have another session and I'm already late by 5 minutes. Okay, so I'm going to end the session right now, right here, everybody. I hope that you all understood, everybody. Extremely sorry for that one mistake I made. I don't know what I was thinking. But I think I will just trim that part so that other students do not get confused. You all understood, but the other students might get confused. So I will just trim that part, okay? Chalo, bye-bye everybody. Tata, bye-bye and good night. See you all. See you all in the next session. Oh, the next session is happening on Friday and Saturday, okay? Friday, there will be a strategy-based session and Saturday will be P block mind map, okay? See ya. Bye. Good night.